Welcome back to my course Formal Methods for System Verification. In today's class, we will learn Tseitin Transformation. To recap what we have learned in the previous class, we learned various normal forms. Why do we need normal forms? We have seen that when you try to check the satisfiability of a proposition formula, if the formula is in some uniform way, I can develop my procedure efficiently, right. So, the normal form what it does, it convert your formula into some uniform way, and we have learned NNF, CNF and DNF. Okay. We have also learned in the previous class how can we take a normal formula and convert into CNF and DNF, right. But the problem that we have seen in that process, that the conversion, after conversion the formula size is exponentially high, exponentially large as compared to the original formula, right. And that is problematic, because even if you have an efficient algorithm, if the formula size is exponential, it will not help, right. Eventually your algorithm will take exponential number of time. So, what is the solution? So, to convert the normal formula into CNF, we use Tseitin transformation. So, this ensure if your formula is converted into CNF using Tseitin transformation, the formula will be equisatisfiable and the size of the converted formula is of linear increase in size as compared to the original formula. It is not in exponential. Let us say the original formula have say n literal, this formula will may have the size or total number of character in your formula is n, it may be 6n, 5n, 3n, but it will not be 2 to the power n, right. So, this is how this Tseitin transformation makes sure that I have a uniform representation of a formula, any formula into CNF, and that has of linear size of the as compared to the original formula, right. So, before going into this, we also want to make it clear that the conversion make an equisatisfiable formula, not equivalent formula. Okay. So, I hope you remember the difference between equisatisfiable and equivalent, but just to recap, what is equivalent? Equivalent means for all possible input, the original formula say f and the converted formula say f1 will be converted into same truth value, right. So, if you give input 1 or the interpretation 1, if the formula 1 f become true, this will also become true. After another interpretation say I2, if f become false, this will also become false, and so on, right. On the other hand, for equisatisfiable, it says that if the original formula is satisfiable, this is also satisfiable, and if the original formula is unsatisfiable, this is also unsatisfiable. But here it does not say that for interpretation I1, if the formula is say satisfiable, converted formula F1 is also may be satisfiable for some other interpretation, may not be the same interpretation, right. So, what I am trying to say that, so if f is satisfiable, f is sat implies there exists some interpretation I such that I satisfies f. Now, f1 is sat implies there exists some interpretation I1, this is not I, this to be noted, such that I1 satisfies f1, right. So, this I and I1 can be different. Okay. On the equivalent case, these are equivalent if say for all I, if I satisfies f implies I will also satisfy f1, and for all interpretation I1, if I1 satisfies f does not satisfy f implies I1 will also does not satisfy f1. So, the evaluation of this formula for all interpretation is same. Here it is equisatisfiable. So, for our case, because I want to check whether the formula is satisfiable or not, so equisatisfiable is enough for me, but I cannot replace this Tseitin transform formula into the original formula in the actual solution or actual problem. Only for satisfiability checking I can do that. Okay. So, now this is the steps for Tseitin transformation. Usually we introduce an auxiliary variable for each operator, and then I will create equisatisfiable clauses for each operator, and then I will combine the clauses. Okay. So, these are the steps. So, I will explain with an example. Let us say I have this formula which is not in CNF, I want to convert this into CNF. So, what I will do? I will construct the abstract syntax tree of this, or AST, which is quite simple. So, what I will do? I will basically, you can think about that I have this x1, x2 and x3, right. So, I will create x2 and x3, and then I have implication here, which is x1 implication this, right. So, this is my AST. So, this is what I have constructed, this is the implication and this is AND. So, given any formula I can construct this. Now, what I do? I will create a new auxiliary variable for each such operator. So, I have two operator implication and AND, I will create two auxiliary variable A1 and A2, right, A1 and A2. Then I will write clause for each of such auxiliary variables. So, my first clause is C1, which is I will write A1 by implication x1 implication A2, right. So, what I will say, this auxiliary variable implies this operation, and what is that operation? X1 implication A2, x1 implication A2, and this will by implies that, right. That means this and this means that, right. This is how I will write this. Then I will take say C2, which is for this one. Here I will write A2 by implication x2 and x3, right. So, the operation is x2 and x3. This auxiliary variable implies this and this implies the auxiliary variable. So, this is what I will write, and top of that I will write A1 for the top level one, not the other auxiliary variables. So, these are the clause I will get in my CNF formula, but you can clearly see here that these are not in CNF yet. I have by implication, implication and all, but we can simply convert this into CNF by applying the conversion of this into equivalent and or and negation, right. So, I will show you that this is what I mentioned, that I will get three clauses. For each operator I will get a by clause like this, and for the top level operator I will get this one, right, and my CNF formula is combination of these three clauses. So, if I can convert this one into CNF, then I am done, right. So, I will now show you how that works. So, my C1 is effectively A1 by implication x1 implication A2. What does this mean? A1 implication this, A1 implies this, and this implies this, right. So, x1 implies A2 implies A1, right. So, these are two part, right. Now, if I take this part, which is A1 implication x1 implication A2, which if I represent this implication, this is not of A1 or this, right. So, this is basically not of x1 or A2. So, this is a disjunction of literal. So, this is one of the clause in CNF. So, this is already in CNF. Now, I will take this one, which is x1 implication A2 implication A1, which is equivalent to not of x1 or A2, right, negation of that or A2, right. And then if I distribute this negation here, it will be x1 and A2 or A1, right. So, this is A1. So, this is not in CNF, but I can distribute this here, which is equivalent to x1 or A1 and A2 or A1, right. So, this is in CNF, because this is disjunction of clause 1, this is clause 2. So, this is in CNF. So, I got three clauses, right, three clauses I got from this one. So, I got three clauses which I have explained now, right. And similarly, if you take the clause 2 and if I do the same way, I can show you that I will get three clauses like this. Okay. So, here I think there is little bit of mistake. So, I can actually show you what is happening. So, I will get A2 implies x 2 and x 3, right. So, which is equivalent to not of A2 or x 2 and x 3, right, which is equivalent to not of A2 or x 2 and not of A2 and x 3, right. So, this is I get two clauses from this one, and from this one what I will get. So, which is x 2 and x 3 implies A2, right, which is equivalent to not of x 2 and x 3 or A2, which is equivalent to not of x 2 or not of x 3 or A2. So, this is again CNF. So, I get three clauses, right. So, overall I will get these three clauses, right. So, three clauses I got. So, overall I will get three clauses from the clause 1, three clauses from the second operator and one clause for the top one, which is A1. So, this is the three clauses I got from C1, this is the three clauses I got from C2 and this is for C3. So, this is my equivalent CNF, which I got from the original formula. So, this is the transformation, very simple, right. In general, what is happening? If you look into this carefully, I have some syntax tree, I have some node which can be any Boolean operator, it can be AND or NOT, implication, by implication, XOR, NAND, anything. So, what is the generic form? And I have a auxiliary variable. So, generic form is some A by implication whatever the operator of two variables, right, say x1 star x2. So, this is the generic form of the clauses that I am going to get for each of them, right. And I have seen that whatever this operator is, I will always get three clauses. Okay. So, this is basically saying that it is not exponential growth, right. So, essentially my generic new clauses is coming like A1 by implication A1 star A2 for some operator star, it can be any Boolean operator of two propositional constant AB and the new variable is A1. This is what I get, and from there I have already shown you two cases, but you can actually check for any cases you will always get three new clauses, right, which actually helps. So, that is why this Tseitin transformation generate formula which is not in exponential size. Okay. So, this we have learned. Now, I will show you that the case for where I get actual exponential size in CNF. If you remember in my previous class, I have taken a formula like this, where this is actually in DNF, which has n clauses, right, conjunction of the literal and disjunction of the clauses, which is in DNF. It has kind of 2n variables, right, and n number of AND operator, 2n variables, n number of AND operation and n minus 1 number of OR operation. So, this is the overall size. What is the size then? You can think about the size is effectively of 2n variables. Okay. Now, when I convert this formula into CNF, I usually get exponential number of clauses. How? Here every variable will multiply with the other variables of the other clause, right. So, if there are n clauses, so I have n clauses effectively and it has two variable. So, each of them will come multiply with the other one. So, it is 2 into 2 into 2 into 2 into n, which is 2 to the power n, right. So, how the clauses will come? So, x1, x2, then x3, then x1, xn, right. So, this will be clause 1. Then this x1, x2, x3 and so on, and then I will take y1, yn, right, that will make clause 2. Similarly, then everything will be same for the previous column, which is say x n minus 1 and y n minus 1. So, in the first two clauses I have taken x n minus 1. Now, I will take y n minus 1 and I will again one time I will take x n, one time take y n. So, this way every variable will comply with another one and I will effectively get 2n clauses. Okay. That is why this CNF has exponential number of clauses that we have discussed in detail in the previous class as well. Okay. Now, I will show you that if I do the Tseitin transformation for this formula, I will effectively get linear size formula, right. So, what I will do? I have this formula which I have to convert first into AST. So, this is the AST, the construction is quite simple. So, what I am doing here is you can think about that x1 and y1, this AND is happening here, x1 y1 AND, then you have x2 y2, this is x2 y2 and they are getting OR here, right. And then this is x3 and y3, then you will have x4 and y4, and then finally you will have xn yn, right. This is xn yn and they are getting OR here. So, these are the OR operator, this is OR operator and these are AND operator. So, this is the AST I will get. Okay. So, once I have get this AST, then what I will do? I will basically add auxiliary variables, right, for each operator. So, you will have AND operator. So, let us say I have use variable A1, A2, A3 to AN for AND operator, right. And for each OR operator I have used B1, B2 to Bn minus 1, because I have already told you there are n minus 1 OR operator. Okay. So, now the clauses are very simple, right. So, clauses are, you have clauses like A1 by implication x1 and y1, right. Then for A2, which is x2 and y2, this way AN by implication xn and yn. So, this I will get for A1, A2, A3 to AN, right. Similarly, for this OR I will get B1 by implication A1 or A2, right, and then B2 I will get B1 or A3, right. So, this way I will get Bn minus 1, which is Bn minus 2 or An. So, these are the clauses I will get, and I have already shown you that usually I will get 3 number of clauses for each of them. So, I will get n number of clauses. So, I will get 3n here, I will get the n minus 1 here. So, 3 into n minus 1, which is 3n minus 3 clauses, and I have the top level one, which is 1. So, 3n plus 3n minus 3 plus 1, which is 6n minus 2 number of clauses, and the new variables I have introduced 2n minus 1. So, earlier the size was 2 to the power n, I am getting now 6n size of number of clauses. So, which is linear growth, right, not exponential growth. So, in general we will get clauses like this ai by implication xi and yi for all I and operator, and for OR operator I will get the generic term is like this bi equal to by implication bi minus 1 or ai plus 1 for I greater than 1, and for B1 I will get A1 or A2, right. This is what I get, A1 or A2, and for other cases B1 A3, B2 A4 and so on, right. So, this is what I write in generically. Total number of clauses I will get effectively 3n plus 3 3n minus 1 plus 1, which is 6n minus 2. So, one might argue that I have taken this clause, right. So, from there I will get 3n clauses, right. So, just to recap what we have obtained for each of them, right. So, essentially I get 6n minus 2 clauses and new variable is 3n. So, this is effectively the 3n for AND operator, 3 into n minus 1 for the OR operator and 1 for the top level variable, right. And 2n is the original variable and 2n minus 1 is the new variable. So, total kind of 4n minus 1 new variables. So, this shows that Tseitin transformation gives you an equisatisfiable formula which has linear growth in size. So, the problem is solved. Okay. So, I will now prove that Tseitin transformation indeed give you a equisatisfiable formula. Okay. So, the idea is very simple. Your original formula was satisfiable. So, there is some assignment is already there for each variable, right. Only new variable is basically this A1, B1, right, whatever the auxiliary variable I am adding. So, what I have to show that if I have some assignment I, so I convert say the formula f in say for my proof I have taken formula phi is converted into T phi, okay. And I basically this is satisfiable. So, it means there exists some I for which I satisfies phi. This is I know. I have to construct, right, I will have to construct some I dash which will satisfy T phi, right. So, I will basically this proof is proved by construction where I will show that how I can get I 1 from I. So, what is there in T phi? I have all the variables that is there in phi. So, I will copy the assignments from I to I 1 because those variables are there. So, if you remember here, if you see here my original formula was you have x 1 x 2 and now I have a 1 a 2 also, right. So, original formula was this, right. So, this x 1 implies x 2 and x 3 and the converted formula is this. So, this x 1 x 2 x 3 are already there and your new variable is a 1 a 2 the auxiliary variables, right. So, what I will basically show here that in my I all these x 1 x 2 3 values are there, I will copy them into I 1 and I have to just decide what is the value for this a 1 a 2 a 3 all these auxiliary variable and that is very simple to identify. So, what I am saying that, so I have the generic term is like this, right. A 1 by implication x 1 some operator x 2. So, this is this x 1 x 2 occurs in original formula and I already know their values. Let us take an example, let us say this is AND, okay, and let us say in my original formula this x 1 and x 2 was said true, right. So, this is also true, this is also true. So, now this part is evaluated to true because true and true is true. Now, to become this formula true I have to set a 1 is also true. So, I get the value of a 1 based on the value of x 1 x 2. Now, let us say I have in my original assignment I x 1 was true and x 2 is false and that makes the original formula satisfiable, okay. But here this x 1 and x 2 will become false because true and false is false. Now, this part is false and this is kind of by implication. So, then a 1 will be 0 because 0 by implication 0 is true, right. I have to make this term true, that is all, right. So, based on the value of x 1 x 2 I can decide what is the value of a 1 a 2 all the auxiliary variables and that is how I construct I 1 and that will satisfy your formula because finally your CNF formula has all this conjunction of these clauses, right. So, for each such clauses, so what I will do, I will effectively, I will basically I know the value of this x 1, x 3 and all, I will decide the value of a 2 and then here a 2 value I know and now I know the value of x 1, from there I will identify the value of a 1 and so on and that will satisfy this formula, right. So, I can show that if your original formula is satisfiable, I can construct an assignment or interpretation which will make my converted formula is also satisfiable, right. So, that is conclude the proof effectively, right. So, with this I will conclude today's class. In the next class, I will take this Tseitin transformation and I will show that various further optimization is possible to reduce the size of the formula further, okay. Thank you.